qubit, there are two different types of graph. Okay, there's two different types of graph. The first type is like a purely y equals to x cubed. Okay, y equals to x cubed. So for this type of graph, there's a particular shape. So anything in the shape of like y equals to a x minus h cubed plus k. Okay, anything in this form, okay, anything in this form will have a particular shape, but you don't need to know that yet until year 11. So what you need to do is only understand what x cubed looks like. So x cubed will look like this, okay, increasing function. It's already in the factorized form. The factor is x, x, and x, so 3x. So what I would do is, that's the shape of a cubic function, and it's symmetrical. Well, it should be, looks better. Okay, it should look like that. So we have the point 0, 0 here. This point is called a stationary point of inflection. Okay, stationary point of inflection. And I know I should label another point, maybe 1, 1, maybe negative, negative 1, like, doesn't matter what you have, so you need to label another point. At least 2 points on the curve. Okay, at least 2 points on the curve. So that's the basic shape of the graph. Okay, that's the basic shape of the graph. So if I'm giving you, can you see this general formula? It looks like the quadratic turning point a lot. Okay, that looks like quadratic turning point. It is called a stationary point of inflection form. So instead of a turning point, we have a stationary point of inflection. Okay, instead of a turning point, we have a stationary point of inflection. So I'll just write another example for you. Let's say y equals to x plus 1 cubed. Well, let's say a minus 2. Y equals to minus 2x plus 1 cubed plus what? Let's see, plus 16. 16. Let's go for 16. But 1 times 2, 4. Let's go 2. Yeah, go 2. Okay, I don't want to make it too large. Let's go for 2. So have a look at this form. This is the form I write above. Okay, a equals to negative 2 in this case, h equals to negative 1, and k equals to 2. Okay, ax minus h cubed plus k. Okay, so x plus 1 is minus negative 1. Okay, x plus 1 is minus negative 1 cubed. So I want to sketch this graph. First of all, I want to say h comma k must be the stationary point of inflection. Okay, h comma k is called the stationary point of inflection. So what I will do is find that point. Okay, the point is minus 1 and 2. Okay, it's minus 1 and 2. Okay, that's our point. And then we look at a value. I know the shape will be this shape or this shape. It depends on the a value. A is greater than 0 here, and a is less than 0 for that. Decreasing for less than 0, greater than 0 for increasing. So I know the middle point is h comma k. Okay, middle point is h comma k. So for this one, I will have a shape roughly looks like that. Okay, roughly looks like that. It's a decreasing graph and stationary point of inflection there. It's like roughly like that. But I need to make it more accurate. I'll find when x equals to 0, what y equals to. X equals to 0, y equals to minus 2, 1 cubed plus 2. And that is y equals to 0. So it will pass through the point of origin, 0, 0. So the shape of the graph is just like that. Okay. It's like, well, my shape is not looks nice. So you have stationary point of inflection here, and then pass through the point 0, 0. So the stationary point of inflection is -1 and 2, and you also know this graph passed through the point 0, 0, and it's a decreasing function because a is less than 0. Okay, a is less than 0. That shape only worked for the general equation, looks like the turning point one, okay? Ax minus h cubed plus k, and h comma k is the stationary point of inflection, okay? H comma k is the stationary point of inflection. And A decide whether it's an increasing graph or whether it's a decreasing graph. Okay, that's A less than 0, that's A greater than 0. So that's how we sketch for this type of formula. So I'm not going to investigate too much on that. I will go to example 2 and tell you how to sketch a general shape, which is called the factorized form. Okay, how do I sketch a factorized form quadratic? So I need to factorize that first. Okay, I need to factorize that first. So in order to factorize that, I'll just use the table method. Okay, 1, 2, -5, -6, and -1 will work. -1, 1, -1, -6, 6, 0. That one worked. So I will have y equals to x plus 1, x squared plus x minus 6, and then further factorize x plus 1, x minus plus 3, and then x minus 2. That's my factorized form for this graph, and you can check your factorized answer. It should be the same, looks like that. Okay, why I want to make it into the factorized form? Because I want to find x-intercept. Because I want to find the x-intercept. Okay, so if I don't know that, I can't find the x-intercept. So what is the x-intercept? Is when y equals to 0. X plus 1, x plus 3, x minus 2 equals to 0. Therefore, we have x equals to -3, -1, and 2 as my x-intercept. Okay, that's my x-intercept. I'll definitely have x-intercept there because when x equals to that, your y will be 0. So I will sketch that. I'll plot that on this first. Okay, I will plot those points on that. So I'll have -3 here. I have -1 here. And I have 2 here. Okay, those 3 points are the point of intercepts. Okay, are the intercepts. So we have -3, 0, -1, 0, and 0, 2. And also I should have y-intercept at 0, -6. Why 0, -6? Because that's the constant here. You sub 0 into the function, you have y equals to -6. 0, 0, 0, and y is -6. So I should have -6 here. Okay, after that is the fun step. Okay, so you can think about that's a piece of cloth, and then you have all these holes on that. And then you think about doing swing. Okay, that's the needle. You choose a place to start, and then you go through all these holes one by one. Okay, so where do you start? You always start from your right. If you're trying to sketch polynomial, you always start from the right. So you start from right, but you have above x-axis or below x-axis. What you look at, you should look at the leading term. Do you have a positive leading term? If you have a positive leading term, you start from the top right. If you have a negative leading term, you start from the bottom right, okay? At the top right or bottom right. So for this one, my leading term is greater than 0. So I will start from top right is somewhere here, okay? I start from that. And then which hole I need to go through? The first hole I need to go through is the 20. Sorry, I write this wrong order, 20. I will start from the right and go through the first one. Okay, the next one I will go through is that one. Can you see there's another hole here? And I want to go back to that hole. I need to turn up to pass through that one. And I need to go down to that one as well, okay? I need to go down as well. So that's how we do it, okay? So just go through every single hole, okay, one by one, yes?
I do not care how you go.
It doesn't matter. For year 10, we don't really care how high you go up because you can't tell yet. So, yes? You won't know the turning point in year 10. You can't find it. That's for year 11. Now they learn it, how to find the turning point. So you're not learning it yet. So don't worry about where is the turning point. But I want you to know that your turning point is different from the quadratic graph. You're not going to have it in the middle. Okay, you're not going to have it in the middle of two x-intercept. So you don't know where is it. You know it's somewhere between those two values, but it's not the middle of two x-intercept. Okay, it's not going to be, well, it can be the middle sometimes, but most of the time it's not going to be the middle. So what you will do is just sketch the rough shape of it. What you all need to do is label all the x-intercept and y-intercept. That's it. And the shape correct. Okay, that's it. So it depends on where you start. So you start from there, and that is the shape of your graph. Okay, you just make sure where is your x-intercept, where is your y-intercept, and where do you start the graph. You just need to think about those three things. So first is the x-intercept. X-intercept will be done by factorize the equation and use non-factor law to make it equals to 0. Second, I will use y-intercept, which is sub x equals to 0 in. And number 3 is decide where to start. Okay, start area. So start from the right top or right bottom. And then how you go through all these points is just go one by one. Okay, just go one by one. Any questions? Okay, this method is not only work for cubic, it's also work for quartic, also work for power 5, work for any polynomial. Okay, this method work for any polynomial. So you just need to find all the x-intercept, and then you need to decide where to start your graph. But it needs to be in full factorized form. Okay, it needs to be in full factorized form. Okay, let's have a look at number 3. Number 3 looks a little bit different because I said it's a repeated factor. So let's have a think what will change if there's a repeated factor. Okay, I want you to factorize it, and I have 1, 0, -3, and -2. I will try -1, that's 1, that's -1, 1, -2, and that's a 0. That one worked. So y should equals to x plus 1 and x squared minus x minus 2. So what I have is x plus 1, and then I have x minus 2, and then x plus 1 again. So what I have here is x plus 1 squared. Oh, well, I'm not going to write square yet. I write x plus 1, and x minus 2. So when you solve for x-intercept, when y equals to 0, x can be -1 or 2 only. There's only 2 values. You're not going to have 3. Even though you have 3 factors, you're not going to have 3 values. Okay, you're not going to have 3 values. So, but the -1 repeated. You repeat -1 another time. You repeat it twice. Okay, if you repeat it twice, that will become a turning point. Okay, that will become a turning point. If you repeat it 4 times, that will become a turning point as well. If it's repeated like 6 times, it's still a turning point. Okay, so if you repeat something for even number of times, at that point, that becomes a turning point. I'll tell you what the turning point means. Let's just label the graph, label the point here. Okay, let's just label the point here. Have y and have x. Alright, I'll label the point. the point you have 0, -2 is my y-intercept. I have 0, -2, and you have 2, 0. Make it larger. That's 0, -2, and 2, 0, and then have -1, 0. Okay, and where do you have 2 points? I have two intercepts here. Okay, at -1, you have repeated twice, -1 and -1. That point will become a turning point. You just note down all of that first. Okay, if you have even number of times repeated factor, 2, 4, 6, 8 times repeated, you will have turning point all the time. Okay, that's the turning point. Okay, let's have a look at the leading term. Leading term is positive, x cubed. I will start from the top right. Okay, I'll start from the top right. Okay, I will go through that point. I'll go through that point. And I'm not going to go through that, but instead that become a turning point. Okay, what the turning point looks like? That's a turning point. Okay, the graph will look like this. That become a turning point. So you're not going through. Instead of going through like before, you will turn down because that's a turning point. Okay, you turn down like this. So that's the shape of my graph. Okay, that's the shape of my graph. Okay, if you have something repeated odd number of times, what that will become? Well, like a factor, x minus a to the power of n. If n is even, then a0 become turning point. If x minus a to the power of n is odd. Okay, or like 3, 5, 7, not including 1. A comma 0 become a stationary point of inflection to the power of n. Okay, how many? Because this one you have x plus 1 to the power of 2, and then x minus 2. It repeated 2 times. So x to the power of n, let's say repeat n times. So x minus a times x minus a times x minus a. So repeat like 3 times or 5 times or 7 times, that become a stationary point of inflection. I'll show you what the graph looks like if it's a stationary point of inflection. Let's say we have y. I just draw this form for you. Okay. And I have 1 minus x. Not 1 minus x, no, 2 minus x, 2 minus x. Well, instead of write 2 minus x, I will write minus x plus 2. Okay, that looks better. Can you have a think? The highest leading term, the leading term should have a negative value. Do you agree with that? The leading term got a negative x. Like, because you have positive x to the power of 3, x to the power of 2, and you have a negative x there. So your highest term will have a negative x to the power of 6. Okay, the highest term is negative x to the power of 6. So the leading term is negative. Your leading term will be negative. Your a is negative. But like, it doesn't matter. Let's sketch the intercepts on the graph first. Okay. What you have is minus 1. Okay, minus 1, 0. And 1, 0. And then you have 2. Okay, that point is 2, 0. Okay, you solve that equals to 0, and that's what you have. And therefore, we will have like y-intercept is when x equals to 0. y will be 1 times 1 times 2, and that should give you 2. So 0, 2 is the y-intercept. Zero, 2 is here. Okay, 1, 1, 2. Okay, because the leading term is negative. Okay, leading term is negative. We will start from the right bottom. Okay, we'll start from the right bottom. And also, x plus 1 repeated 3 times. So negative 1, that will become a stationary point of inflection. X minus 1 squared repeated twice, that will become a turning point. And where do you start? You start from the bottom. You start from here. So you will go through the first point is x here. Okay. Something like that. And you need to turn to that point. But that point is a turning point. You're not going through that. What you have is a turning point. Like this. And what do you have here? That's a stationary point of inflection. You still go through that, but that will become stationary. Sorry. That's just not. Okay, something like that. It's just like a bad sketching, but like the rough shape looks like that. Okay, the rough shape. Yeah, this becomes a turning point. First, you start from here, going up. Go here, you're not going cross because it's a turning point. You turn it up to that point, and that point should be a stationary point of inflection. So that will go that. Well, but my graph is definitely not. You're definitely not going to have it like that because it's so hairy. You definitely lose mark. So you need to have a smooth graph. So draw a rough shape first, and then use pencil or pen, just change it. And that's the rough shape. So what I will have is okay, that's the shape. Well, this point should be a stationary point of inflection. Okay, something like that. Okay, so you repeat it even number of times, that become a turning point. You have a factor repeated odd number of times, that become a stationary point of inflection on the x-axis. And then you always start your graph either from the top right or bottom right. If the leading term is positive, up right. If it's the leading term is negative, bottom right. Okay, and then you complete your shape like that. Yes?
Wait, sorry. You had a last point, like the first point here. But, should it be like that? Like the, like that?
Well, it's more like
Yeah, it can't be like that after the point or like
on the point, on the point, on the point. That point is the stationary point of inflection. What is it?
So after the point, it just goes like a curve. It doesn't go like this.
Okay, so that is your x-intercept, like that.
Oh, okay.
Make sense?
Yeah.
Yes?
When you're coming down the y-intercept, is it necessary
To,
you know how you've like curved it towards the...
well, my graph is just a little bit weird. I will just go for ones like that. That is my graph.
Is this okay for the stationary point of inflection?
Yeah, yeah, yeah. Okay, that can be a better graph. Okay, that can be a better graph. Some shape like that. Okay? Any other questions? If you don't have it, listen to me now. Shh. If you don't have any questions, stop talking, please. Yes? Stationary point of inflection?
On the y.
That one?
And that one.
Well, it's not necessary to be the y-intercept. So better not to sketch the turning point on that point. To show your understanding, it's not necessary that point. That point is the y-intercept, but not the turning point. It can be the same, but like not necessary. Why? It's not the middle. Your turning point not going to exist in the middle. You are not going to have your turning point exist in the middle of two intercepts. So that's -1, that's 1, right? But not going to be in the middle. So it's not going to be there. So it can be sometimes, but like not necessary again. So it can be here or here, like shifting. So don't worry about where's the turning point. You just need to know the shape looks like that, and the point of intersection looks like that. Turning point looks like that. That's all what you need to do. Okay, it's not that strict yet. Okay, so just needs to know the shape. Go back to this graph, to this quoted graph. Okay, factorize that. -7, that doesn't work. So you may try -1, -1, 1, -1, -10. 10 minus 2 is 8, minus 8 is 0. This one worked. And I need to keep going because that's still a cubic. So you keep using those numbers to factorize. That's a cubic. So I need to go for another line. Well, maybe try 2, 1. Well, 1 doesn't work already, so we're not going to try 1 again. So 1, 2, 3, 6 minus that minus 4, 8, 0. That will work again. So y should equals to x plus 1, x minus 2, x squared plus 3x and minus 4. So y equals to x plus 1, x minus 2, and x plus 4 and x minus 1. Okay, that's the factorized form. Now what I need to do is put that on the xy x-axis. So the y-intercept is 0, 8. I know that is 0, 8. So I'll sketch it here, 0, 8. And then I have -1, -4, 1, and 2. Okay, those 4 points. So -1, 0, -4, 0, 1, 0, and 2, 0. Okay, those 4 points. And you look at your leading term. Your leading term is x power 4. Okay, top right. Okay, top right. That's 5 points labeled. I know all the x-intercept, I know the y-intercept, and I'll start to sketch it. So right-hand side, top. So I will go through that one, go back to that one, go inside that one, like that, like that. Well, my graph always looks quite bad. So okay, go that one, inside, go this way, go this way. Oh, so sad. Make it bigger. Go that way, go through that, go through that, go through here, and go through here. Well, I don't know where's the turning point, so it doesn't matter where you sketch it. Well, the shape is a little bit funny, that's fine, but the shape should roughly look like that. Okay, roughly looks like that. It's like a W shape. The two turning points not necessary to be the same height, but you have a graph similar like a W. Okay, similar like a W. You don't know any information about that point and that turning point. So you just need to label the 4 x-intercept, 1 y-intercept, and the graph is positive shape, okay, going from the right top, and then it's fine. All right. All right, so that's how we sketch it. Okay, I'll go use a lot of example for you how do we sketch it. And let's go to the last one. Okay, it's this question here. This question here is asking you what is a possible cubic rule for this graph. Okay, what is a possible cubic rule for this graph? So I can see this is the x-intercept, -3, -1, and 2. So that's the possible, like not possible, that's the x-intercept, and they tell you the cubic. So what I would do is y equals to, okay, you want a -3, so you will have a factor of x plus 3. You want a -1, I need to have x plus 1. You want a 2, you will have x minus 2. So that's the possible factors. But is that enough? Why not? Why yes or why? Yes is yes. Why not? If you think it's not. Yeah, well, like I can give you an example. I can do a shape like that. This is a cubic passing through exactly same x-intercept as well. Okay, so you don't know the dilation. So you must put the a value in the front to decide what is the dilation for that graph. I can stretch it, I can flip it, I can make it wide, taller, shorter, but it all depends on the a value. So I don't know the a value, I need to work out the a value. Also, if you put the point 0, 3 in, that doesn't satisfy. You put 0 in, so 3 times 1 is 3, and you times the -2 is -6. You're not going to have a y-intercept at 0, 3. So you need a value in the front to help you to make the graph look the same. Okay, so you can have infinite many graphs with the same x-intercept, but with different shape. Okay, different equations. So what I will do is sub. You're not going to sub those 3 x-intercepts. What you need to sub is 0, 3 into the equation. And you have 3 equals to a times 3, 1, and -2. So 3 equals to -6a. Then a is -1/2. A is -1/2. So this equation will be -1/2. X plus 3, x plus 1, and x minus 2. That's the equation. I know the graph is a little bit messy, but that's how much effort it needs to do. It's here. Okay, can you see a is negative, which means your leading term is a negative leading term. You start from the right bottom, and which is correct. Okay, you start your pen here and then go up and then this way, which is correct. If you have a positive leading term, you shouldn't start here. You should start at the top. Okay, it's because it's negative. I start from the right bottom, so that's the correct place to start our cubic. Okay, yeah. You can use that example because that point is labeled, so we use that. If another point was labeled, not the y-intercept, you can still use another point. For example, 2, 5, you can use that point as well. Okay, any other questions for this chapter? Okay, we learn how to factorize, we learn how to solve, and then we learn how to graphing them. So we all need the skill of factorizing. So you must know how to factorize. And basically we use long division or the table method to factorize it.